Okay, we're hucking gourds now, right? We're on this building. Here's this building. The building apparently is 12 meters tall, right? The gourd goes, oh, it's thrown downward. Oh my, here's a gourd. Looks a lot like a ball thrown downward. It's got initial velocity of 4.12 meters per second. And with what velocity does it strike the ground? Time to take. So this is going to be from release to the ground, right? To the ground. Okay, and then our displacement is down 12. A lot of you guys missed that, but there it is, right? 12.0 meters. And then our initial velocity is negative 4.12 meters per second. Our final velocity is not zero. We don't say it's zero because obviously we're talking about just before it strikes the ground. But this guy is negative 9.81 meters per second squared. I'm putting units on things. What's come over me, right? And then I want to find the velocity. I think what I'll do is I will use no t. Let's do that. Keeping in mind that we'll only get the absolute value of the final velocity, we will have to put a minus sign on it because it's definitely going to strike the ground going down. Okay, so v squared is u squared plus 2as. So let's see, v is the square root of negative 4.12. Okay. Be very careful when you're putting this in your TI calculators. That negative number will not square properly without the parentheses. Okay, it's not really negative. It's, I don't know. It's my pet peeve. Okay, plus 2 times negative 9.81. And then this is the negative 12, right? Okay, here, let's draw a little line here to separate this. Got to separate the diagram. Stay separate. No, oh no, it went above it. There. Okay, there we go. So a lot of people missed that minus sign right there. Don't miss it. Okay. So square root of, I'm just not going to put the minus on there, 4.12 squared plus 2 times negative 9.81 times negative 12. Notice that my answer is 15.887 meters per second. Notice that it's bigger in magnitude than this one, right? So it should be going faster when it hits the ground. Of course, that's the absolute value of v is 15.887. That means that it could be positive or negative, right? Okay. Clearly, when it hits the ground, it's going down. So negative 15.887 meters per second is our, and then of course this is correctly rounded to 3 sig figs, right? Okay, so now we want to find the time to reach the ground. I could use ut plus 1 fat squared, but that would be quadratic. I don't feel like it, so I'm going to use my value for this, right? So I'm going to use v. That is an 8. Is that an 8? Yeah. I'm sort of special when it comes to drawing these. Okay. So v equals u plus at. Right, so it's negative 15.887. It's actually 887. I'll say 8876, right? To be just hyper about this, right? And then that equals negative 4.19. No, 4.12, sorry. 4.12 plus negative 9.81. I'm running out of space. Okay, times the time. Okay. Now we're set. We're going to solve this guy right here. Let's see. Okay, divided by 9.81. I get 1.1995 and blah, 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 blah seconds, right? And now you got to round that. This is the hardest part. You got to round that to 3 sig figs. So this would round up, right? So then it's like 1.20. Yeah. Yay.